All right, welcome everyone to stage 2. Before I get started with introducing the session, just wanted to reiterate, if anyone hasn't downloaded the AWS Summit app, please do so. That's how we're able to get feedback for our speakers. Now, to introduce the session for today, we have a session on mitigating OWASP top 10 CI/CD security using AWS security services. This session is a level 300, and today you'll learn more about securing CI/CD pipelines, aligning with OWASP top 10 CI/CD risks. Now, without further ado, it's my pleasure to welcome on stage May Kyaw.
Hello everyone, I hope you are enjoying the session today. We just want to start it off with just talking a little bit about the security. Security at AWS is a job zero. We built a lot of the foundation security through AWS services. And with that, I just want to talk through today on the OWASP top 10 CI/CD security. And then we're going to go into a mitigation strategy of how we're going to mitigate those OWASP top 10s. And then go a little deeper into a pipeline security with permission boundary. And then we'll wrap up the session with giving you some key takeaway of full CI/CD pipeline. Before we go deep into a pipeline security, let's take a look at 2024 data. In 2024, Sonatype State of the Software Supply Chain report really painted a picture of our current CI/CD landscape that's directly impacting the security of CI/CD. In just over 1 year, we see 512,000 malicious packages were introduced into our software ecosystem, with 156 year-over-year growth. Dependency confusion flow, 80% of these dependencies remain unchanged. And we continue to see that built environment compromise and secret exploitations are the prime target. With that, I want to touch on the two main components today: security in the pipeline and security of the pipeline. All right, when we say security in the pipeline, it means that your application code, your dependency packages, they're thoroughly tested. We are signing our artifact, validating those artifacts before you deploy into production server, and you are also monitoring those. So that's security in the pipeline. What about security of the pipeline? The pipeline security itself, and pipeline is a key architecture construct to take your production code into the system. Pipeline consists of multiple stages. Pipeline has elevated system privilege. For example, it can pull your source code, it can pull the secrets, it can deploy it into a production environment. A compromise somewhere in this pipeline could have a full-scale production impact. So securing the pipeline is not just important, it's absolutely essential, and this is where we're going to focus on today. With that, please meet Alex. Alex is a senior DevOps engineer whose role is to streamline software delivery while maintaining secure pipeline. Alex faced two challenges: integrating security into the CI/CD pipeline, and secondly, managing software packages and their life cycle. So, this is what Alex is gonna do. Alex researched about the OWASP top 10 CI/CD security, which is the open community standards to help it identify the focus area, but also to understand threat landscape. Then he goes deeper into 4 areas that's relevant to his infrastructure and create a mitigation roadmap. So let's take a look at them. Firstly, integrate identity and access management. At its core, it's about managing the identity, so who or what can access into your critical system. For example, your source code management system, your CI/CD pipeline. That includes both human and programmatic access. And you might wonder, why does it matter? We see that in the Sonatype report, poorly managed identity with a overly permissive accounts are a prime target. So this is how we're going to mitigate them. Alex created a mitigation roadmap that's break down into 4 important pillars. We call it 4C model. So we created this model for easier to follow. So starting with centralize, but firstly, let's build our identity as the first line of defense. Let's create a centralized identity provider. So here you can use the AWS Identity Center, or if you already have one, use federation with Identity Center to get access into your AWS environment. Use AWS organization to have a multi-account environment management and control your centralized permission through them. Next is control. Control is all about continuously scanning all the identity across all your system, mapping the identity with the permission, and tracking their usage. Here we can use IAM Access Analyzer to give you that information. Generate policy that match with the actual usage pattern within your AWS environment. You can use CloudTrail to exercise that principle of least privilege. Next is cleanse. We see that many organizations have user or accounts that they no longer needed. So here we can use the IAM last access information to help you identify those still accounts. Generate credential report to help you identify those end-use credentials. And if you want to take a step further, you can use Lambda with EventBridge to have that automated workflow to automatically disable those inactive users. Next is communicate. So if we go back to the Alex scenario, Alex architecture or the infrastructure needed to talk to another AWS account. The infrastructure or the pipeline need to talk to another third-party API. So for this kind of external collaboration, let's use the temporary credential. Let's give them a time-bound access and cross-account role to really exercise the security best practices. If you're sharing resources with another AWS account, use the Resource Access Manager to securely share resources. So by following this 4 pillars, Alex is not just managing identities, he's creating more robust and resilient identity ecosystem. All right, next items on the list is dependency change abuse. This is about a threat actor tricking the build system to download an intended version. Some popular technique that we see is a dependency hijacking. That's where a threat actor gain access into the package maintainer account and then publishing the malicious version. Or dependency confusion is another technique we see where the threat actor create the package exactly the same name as the internal package name or a common package name and tricking the build system to download that. So for this kind of scenario, how are we going to mitigate that? So we're going to follow these 4C models. Firstly, manage your package through a centralized package repository. You can use AWS Code Artifact, you can use third-party solutions to have that centralized control. Make sure to pull your packages through internal registry or internal proxy, not directly from the internet where possible. If you have a private packages, make sure to register them under your organization scope and only pull through that internal registry. Next is control. Let's log our package version to a known version or pre-validated version. Here we can use Code Artifact with a strict origin control to really limit what version of these packages are added into your repository. And if you want to take a step further, you can use VPC endpoints to have that secure connection between your Code Artifact and your VPC. In Alex scenario, Alex needed a way to scan those libraries and packages for vulnerabilities. So here we are introducing Amazon Inspector to scan those container images that comes from the ECR, so Elastic Container Repository, scan our Lambda function for vulnerabilities, create a vulnerability report, include that into a CI/CD pipeline so that you can investigate and validate before deploying into a production. And then you can use the Security Hub to give you a holistic overview of your security findings. Communicate. I find it a dependency management is a collaboration process. It's a collaborative process between Alex's team, so DevOps team, engineering team, and the security team. So let's keep our policy and alignments and communication across the entire team, how we are securing the system. Maintain the investigator capabilities. So that includes logging. So having that visibility, logging at the proxy layer, logging at your build layer or package layer, so that you have a full visibility through your pipeline. With that, I'm going to hand over to Vasanth, who is a senior security specialist, to talk through the second part of the presentation.
Thanks, May. On a similar theme, I'm going to talk about next two CI/CD risk and the mitigation steps. The first one is insufficient credential hygiene. So what is it? Think of your CI/CD credentials as the keys to the digital kingdom. Secrets like API keys, passwords, and token. How securely it's been stored, how frequently it's been rotated, when and where the credentials being used. In terms of the risk, let's examine an industry lesson from 2021. A widely adopted code coverage analysis tool used by developers in the pipeline subject to notable security incident. Advisories managed to slip into the system and modify the script. Here where it gets interesting. When developer used this compromised tool, it secretly copied all the credentials stored as environment variables. Not a single team, the whole organization was affected. The why it made such a big news, because the development tool is connected like a big web. A single compromised tool has a cascading effect to the whole organization, whoever incorporated into the workflow. It's like finding out the locksmith who made the keys for your entire neighborhood kept the copies for themselves. Industry learned a lesson, and they started scanning the pipeline for embedded secrets. So we're going to look at our mitigation strategy using 4C model. In the centralized phase, create central vault for all your secrets. Organize secrets with clear hierarchies. Pull secrets away from your application code. AWS Secrets Manager can act as a single source of truth. In the control phase, vault is useless if everyone has the key. So apply IAM permission governance. Scope secrets to specific pipeline stages. Enforce least privilege access. Generate temporary credentials. In the cleanse phase, use Amazon Q to detect hard-coded secrets. Scan your repositories for unused stale credentials and remove them. Scan your pipeline for embedded secrets. Rotate your credentials regularly. Security isn't built in isolation, so visibility matters. Use AWS Security Hub as a centralized findings. Amazon Guard Duty can detect IAM compromise, so you detect for any credential-related activities. And track who's accessing and audit the usage of your secrets. When Spotify implemented this change, the control vault, centralized vault system, they cut down the security incident by 40% while reducing the deployment by 30%. Actually, the better security improved the deployment time. So the 4C implementation, what we are talking about, isn't a one-time implementation. It's going to be an ongoing improvement lifecycle. The last one on my list about CI/CD risk is insecure system configuration. Recent study shows 80% of security incident is through security misconfiguration rather than sophisticated attack techniques, which means we have an enormous opportunity to strengthen our system through security best practices. So why it's important? Think of your pipeline, it's like a house. Your resource configurations are doors and windows. Your OS configurations are alarm systems. And application configurations are foundation. A weakness in any one of your systems make your entire structure vulnerable. So in order to understand this risk better, this time we're going to talk about another industry lesson, what PHP team experienced in 2021. Picture this. Developers received the notification and found out unauthorized commits made into main code base. A malicious code elegantly disguised as a typo fix, but it contains a compromised backdoor, could have compromised millions of websites. So what is the attack vector? It's not a zero-day exploit. The repository is simply missing a branch protection rule, a digital equivalent of leaving the keys in the door. Our mitigation strategy using again the 4C model. In the centralized phase, you cannot secure what you don't know exist. Create a central inventory for all your pipeline components. Track who owns which part of your pipeline. Maintain secure baseline. AWS config gives the vital visibility for your entire infrastructure. In the control phase, implement guardrails but not roadblocks. So restrict who can access the build environment and what they can do. Give pipeline permission only the absolutely needed to do the job. AWS IAM, code build, and code pipeline can work together to enforce this guardrail mechanism. In the cleanse phase, keep all your components patched and up to date. Pull the tool away from your pipeline if you are not able to secure it. Clean up the build environments between the runs so that you avoid the credential leakage. Amazon Inspector can scan for vulnerability continuously so that you never get off guard. Security issues thrive in silence. Tools like Security Hub and GuardDuty with integrated alerting mechanism to make sure everybody informed what matters to your organization. Let's shift our attention to another significant challenge which consistently see from our customer environments. How can I safely let my pipeline to create IAM roles and policies in self-service model? We're going to talk about again Alex's lesson. Alex team went from monthly to daily deployments. DevOps leadership team called us a big win, DevOps success story. Many of you probably there. More releases, faster automation, continuous delivery. But under all the progress, there is a hidden risk. When did you last check what pipeline permission do you actually have? Alex team found out in odd way. During the investigation of security incident, they found out the adversary is not targeting the application at all. They're simply exploiting the pipeline excessive permission to gain access to the environment. So Alex team grants pipeline to deploy AWS resources, but there is no way to restrict what the pipeline permissions it can grant. The pipeline job could have access to sensitive data buckets, or it even can create a role with a bigger privileges, admin kind of role, can escalate privileges. Way more permission needed for the pipeline to do the job. The same automation sped up the delivery, now become a big security gap. Think of a second, do you know about your pipelines? What pipeline permissions do you have? What they can access, where they can reach, what data they can modify. Not the permissions you remember giving, the permissions accumulated over the time. But we have a solution for this. Alex team found out a solution how to solve this problem. IAM permission boundaries. One of AWS strongest security, but underutilized security control. Think of permissions boundaries as a guardrails to your permissions. No matter what pipeline roles and policies it can create, it cannot exceed the boundary. Here's how Alex implemented the boundary policies. First, they created the boundary policy. They explicitly denied high-risk actions. Actions like no pipeline can create IAM user, no pipeline job could access a sensitive data. Second, they leverage implicit denials. Unless they're specifically mentioned in the allow statement, it's automatically blocked. The game changer was how they enforced it. They used IAM permission boundary condition key. That key, they made sure the pipeline role, whichever the role or policy it creates, it makes sure the boundary policy is always there. What is the result? Alex pipeline gives the development team able to self-service the IAM needs without worrying about the guardrails or permissions they can exceed. Most importantly, the development team didn't lose the velocity. In fact, they gained autonomy because the security team comfortable giving the self-service model because the guardrails already there invisible built into the system. This approach scaled because the more and more application added, the pipeline boundary policy provide a consistent security so that you don't need to manually review all the IAM permission changes every time you deploy those changes. So we're going to look at all the detailed policies of constructed by Alex team. What do you see on the screen? There is two files. One is automation role boundary permissions.json. That is a policy attached to the roles created by the pipeline itself. The second one is the CI/CD sample.json. This is the one change the Alex pipeline transformed into a better security posture. Let's look into the role in detail. What do you see from the screen? There is a first statement. Allow role creation with attached permission boundary is critical. It allows the pipeline to create the role, but notice the condition at the bottom. It requires a specific permissions boundary to be attached. Without this, the role creation fails. The second statement, create or change only with boundary, extends the protection. It means the pipeline permits to modify the roles and policies, but again, only when the same boundary is attached. The simple but powerful approach means Alex pipeline can still self-service IAM needs. So Alex team went from having the most powerful tool, their pipeline, through the biggest vulnerability using without boundary policy, and become a strongest security control now. It's all happened without slowing down any deployments at all. So you might be wondering, so how do I gonna go about implementing a permissions boundary? Let's talk about some practical approach. You want them wide enough to be reusable across similar workloads, but not so wide so that it won't create unnecessary risk. The key is knowing what to exclude. You definitely don't want your application having powers they don't need. Things like IAM pass role permission, changing the IAM settings, VPC configuration, it's mostly off limit for most of your applications. Remember, just because your boundary is broad, it's not necessarily your IAM role needs to be broad as well. Always fine tune your IAM role within those applications what you provision using the CI/CD. It has to be specific to your applications. Think of this way, your permission boundary is a maximum speed limit set on a highway. And each vehicle, in this case is IAM role, passes through this one. It has to operate within the specific situation according to the application. With this one, I'm going to hand over to May to conclude Alex's learning journey.
Thank you, Vasanth. So let's take a look at Alex's learning journey. You have seen the whole picture. And we want to give you a full CI/CD, secure CI/CD picture. So there's a lot of icons there, so please bear with us. We're going to start from the developer side. So our developer use IDE for software development, CDK for infrastructure as code. We are integrating security at the very right, like at the very start of our pipeline. So we're going to use Amazon Q for secure code scanning, CF and Guard for infrastructure validation. When our developer push code into a GitHub or the repository, we have set our branch protection rules. We're using code artifact to centrally manage our packages and repository. Our secrets are managed through a secrets manager, so no more hard-coded secrets in our source code. In the build and deployment stage, we have SAST, Standard Application Security Testing, with Kyaw for code scanning. We're using Inspector to scan our container images, our Lambda function with the vulnerabilities. Once it has been scanned, we are signing our artifact. So artifact signing is important. We're going to sign our artifact to make sure it comes from the trusted source, it hasn't been tampered with. And next stage, we have an approval rule. So we ask for a manual approval before deploying into production server. Then we have SBOM, software bills of materials, to track all our dependency, continuously scan for vulnerabilities, and then followed by a final verification stage. So we have a final signature verification to make sure that this is the artifact that we want to deploy. Once it's all approved, our pipeline handles the deployment to the production server. Post-deployment, we have a comprehensive alerting and logging system using our security services, our network services, and using AWS config to keep us compliant. So the key takeaway here is that we are integrating security at every stage of our CI/CD pipeline. Having a solid identity and access management, secrets management is super important. Let's implement pipeline integrity and validation throughout our pipeline, followed by a comprehensive monitoring and governance. You have a full visibility of your CI/CD pipeline. If you want to learn more about it, we do have a hands-on workshop and libraries that you can go and check it out. With that, thank you so much for joining the session. If you can fill out the survey so we can improve our session for next year. Thank you so much.
Awesome. Thank you so much, May and Vasanth. It was a great, great session. Just a reminder, if you have not downloaded the events app, if you could please download that, provide feedback to our speakers. Also, we do have our next session starting here at 4:45. That's going to be about simplifying Kubernetes workloads with Carpenter and Amazon EKS Auto Mode. So we'll see you back here at 4:45. If everyone could just leave their headsets on their chairs and make their way out to the back.